Hello, everyone. This is Jan Brugård. I'm the CEO of Wolfram MathCore. And Wolfram MathCore is the entity at Wolfram responsible for the development of SystemModeler. And today I will talk about what's new in SystemModeler. I will basically mix a bit of what's been released during the year, basically since last conference, and then some peek previews of what you can expect from the upcoming release. So it will be a mix and match. And I will try to, I have put notifications or marked those that have been released already with the release number 14.3. So you can see whether it's been released or not. And that will, for everything except the last sort of tips and tricks slide, where I will mix a bit as I want, so it's not necessarily yet released. Some of it will be, other stuff of what I show will not be released yet. Anyways, let's get going. So one thing that has happened since last year is that the library store, meaning the place where you find additional libraries to SystemModeler, and with that libraries I mean modeling libraries, has grown a bit. And this, of course, opened in the other window. Here we have it. So what we have added is a section called recommended third-party libraries. As you might know, there are other Modelica tools, and there's also, just as there are other Modelica users with SystemModeler that develop libraries. And the idea here is to add these third-party libraries, curate them, and add them here. So rather than having to sort of browse around and find the right version on GitHub or whatever, you will have a list here of libraries that we've gone through, that we are testing more heavily than other libraries, and so on. And you will also be welcome to add your own library here. For that, you just have to sort of contact us. Among the libraries right now is you see it's only 4 at the moment. Is business simulation, IBPSA, which is a new library since last conference, photovoltaics also, and then planar mechanics, which we have had actually on the library store for a while, but in a different section. If we look at IBPSA, this is how all these different libraries will be presented. They will have some summary of what they are about. So in this case, it's a library from the International Building Performance Simulation Association. So you can sort of guess what the purpose of it is. And we will have examples showcasing how to use it. And this particular example is a community post. I just wanted to point out that we have been quite active last year on adding community posts to show different workflows that you can do in SystemModeler, especially when you combine that with Wolfram language. And this is actually a very good example of that, where you use SystemModeler and the PDE FEM functionality of Wolfram language in a combination to sort of get a more detailed analysis of your system. And that of course, is one of the more important parts of SystemModeler, that you actually combine it with Wolfram language and can do things, combinations that are that takes you, gives your model extra mileage, basically. Anyways, you can expect more libraries in the store as we go. Probably within a week, there will be a couple more power systems and power grids. And then you will see over the year, one library after another being added. Okay, let's see what, oh, there you go. Another thing that we presented last conference and that was released this spring, was an update of the OPC UA library. So the OPC UA library is a communication library for you to interact with real devices, hardware, mostly used in process industry, but for instance, your appliances home, a lot of them will communicate over this protocol. And the updates we've done to it is especially within security and authentication. So of course, if you're running something online, you don't want anyone to access that data. So security and authentication is super important. We significantly improved the performance and scalability. So for those of you using the OPC UA today, you will find a big increase in speed, which of course is also very important that the communication is fast if you want to sync with real-time data. And we also made it possible to configure your error handling. So you can configure how you want to sort of handle errors, communications errors, which of them are acceptable, which ones needs to sort of some action, and so on. And again, here it's available in the library store. In this case, as it's our own library, we have a bit more examples on how to use it, with including examples of how to use it to create digital twins. And for some reason, my notebook decided to skip this slide, so I'm jumping back to the third-party library store just to show the other library, photovoltaics. So as you heard from the name, it's about adding PV systems or modeling PV systems. So for instance, my colleague Ankit Naik has used that for modeling his own house and see how much value would he get out of installing a PV system on his roof. Would it be something that pays off or not, basically? If we look at an example of that, of a simulation, I should perhaps have built this beforehand, but I didn't, so we have to wait a few seconds for it to build and simulate, and then it will plot. And in this case, what we see is the energy production over a day. So we see this happens to be November. Yeah, it happens to be almost, well, this month actually. And we don't have that much light in Sweden this time of year. So we'll see that the production is 0 for most of the day. But in the middle of the day, we have the power produced, the net voltage, the net current, and so on. And then he's made it possible to reconfigure and saying how many parallel modules does he want to use, how many in series, and to get the performance of these. And a small thing, I might take the opportunity to mention that small thing also that is still important. You see here, of course, this is one where date plots is very important, but we, for 14.3 or 15, we worked a lot with making it possible to use date time all over the product. So it's not just in the plots. You can use it as input for start time and stop time and so on. So you can actually, rather than just work with seconds, you can work with date time, and which of course is in this kind of cases quite convenient. There you go. There's something with my notebook not quite updating as it should. It's sort of, there you go. So if you're interested in more about not specifically these libraries, but presentations related to energy modeling, There will be a presentation, this conference from Anket Naik on modeling of optimizing thermal management in electrical vehicles. I highly recommend that. It shows sort of the value of having access to different libraries and other things you can do in the product. Another thing that we gave a peek preview last conference, and that has now been released, is system validation. So imagine you have this scenario here. We have 5 aircrafts. They are about to do some formation flight. We have given them different paths that they are supposed to follow. Then, of course, there are a bunch of requirements for this that we must fulfill. It could be requirements like the distance between the planes must stay above the distance parameter P for each pair of planes. Or the load factor must be between -4 and 8 Gs for the plane performing the split S maneuver, right? And these requirements in development process are typically this type of just English language requirements. And then the question is, how do you actually, from these initial requirements on your system, how do you ensure that your system actually fulfills it at the end of the day, and how can you use your models to ensure this? So then we implemented something that basically follows a process where you just check, oh, is my system actually working? Is it fulfilling the requirements? If it isn't, when does it fail? And how does it fail? And yeah, you see it's sort of half updating the notebook. There you go. I guess that's an effect of running bleeding edge installations of both System Modeler and Mathematica, that or Wolfram app, that things like that can happen. But we have a full language where we have a function SystemModelValidate with sub-functions such as SystemModelAlways that sets a requirement of something that has always to be fulfilled, and others that might be SystemModelUntil. So the aircraft must stay above 60 meters per second, stall between until the landing gear is fully deployed, for instance. So with this set of functions, you're able to take that sort of text and formulate that in a systematic way in order to actually test your models. It would give you things like this. Again, let me go back and forth. It's sort of updating half the slide at a time. Where you can see here that we have here Tom Cruise. He's out on a mission, and we want to know if the aircraft and the pilot can sustain some specific condition when it comes to how many Gs you're allowed to take to put there on the aircraft. So in this case, SystemModelAlways is used, and then a region is used to define what is actually allowed when it comes to load factor and velocity. And that is used to validate 2 different scenarios, one with a normal pilot and one with Tom Cruise. And once we simulate that, we'll get some, we'll do region plots to see how they perform. And we can see, well, first here we can see that the one with the normal pilot actually fulfills the requirements. It's within the limits of the aircraft, while Tom Cruise pushes it a bit more than he should, so it fails. And if we look at the region plot with the 2 scenarios, we see them here, how they are sort of flying with velocity and the G forces they have. And if we zoom in a bit, we see that the green one because we approve of that flight. The Tom Cruise flight goes, this is where he goes beyond the actual limits of the aircraft. So this kind of way, and you can go through and test systems and verify that they are fulfilling your requirements. And this can combine, of course, you can add uncertainties and things like that to make it more complex. And you want to understand more about what you can do and how to do it, then you have Sergio Vargas' presentation, From Requirement to Validated Design. Something that has not yet been released is, but will be released in coming version, is the ability to train surrogate models. So what is a surrogate model? Assume we have a model like this in SystemModeler. Or it could be bigger, it could be smaller, but let's say we have a model that we drag and drop together. And we want to use it, but it might be too slow for the purpose we're using, or for other reasons we want to obfuscate what's within it. Then you can do a surrogate model, which is basically a simplified approximation, mathematical approximation, that replaces this sort of more complex system and more detailed system. But that still mimics the behavior. And this, the purpose for this would be, for instance, in optimization, you can run it faster and thus sort of run several rounds and get faster to an optimized system. You might do design exploration where you vary things and see what happens if this and if that automatically, or use it in control and so on. Then this is a good thing to use. There you go. So if we look at that, so for instance, this would be one of the use cases, right? That let's start from the beginning. You have some data where you want to fit the model to, and then after a while, sort of it's fitted. To do that is basically sort of just one function that will be system model surrogate train, not the shoo-shoo train, but training it. So you create, use this with to train your surrogate model, and then once you have it, it will be a system. You can use system model surrogate to query it about a system model version of it, a neural net version of it, a parametric function of it, and so on. And if you're interested in understanding more in how this can help you and how to work with it, then there's a presentation, Train Your AI with SystemModeler, that contains this, but also other stuff. And that is by Ankit Naik and Sergio Vargas, where I think Ankit is presenting mainly, but it's those two that have prepared the presentation together. Okay, let's see here. Perhaps if I do this way. Oh, there you go. Before concluding, there are a bunch of, let's say, leftovers that doesn't really fit to some cool presentation, but are really valuable as such. So I thought I'd put together sort of a bit of a final tips and tricks example. And this one is the one combining things from 14.3 and 15. And just to list them first before I go through them and show what they mean, what they are about. We have something live tuning and calibration. Calendar time I already just quickly showed you, so I will skip that. expression graphics, connector sizing, code formatting, and local balance. So let's see what this is all about. As a simple example, I prepared this one, which is, you might recognize it from our introductory examples. So I took what's available in our introductory examples since before, and I modified it slightly. So what we have here is a system of 3 tanks, each of them with 1 PI controller. And then we have an input signal here. We could see this as let's say, this pulse being some representation of the amount of rain. And this is probably the Basque country or something like that, because the way I put it, there's basically rain all the time. So Norwegian coast, Basque country, something like that. And what we want to do in this case, we want to control these tank levels so they end up at some specific reference level that we give them. So the question here, what's new in this? Well, the new thing, if we look at these tanks, we can see the icon here. If I now change my init value for H init, so that the initial tank level, let's say I put that to, it's 1 meter now, I change that to 0.5, then the icon updates. And the same way, if I change PI control 2 here to, it says the reference value should be 0.4, let's say I change that to 0.6, then this line here changed. Let's change it back so you have time to see it. It's not perhaps the most brilliant graphic I ever done, but I hope it serves to show the principle of what you can do. The way you do this, let me open a tank here, is in the icon, just as before, you have been able to set dynamic graphics where you can set equations here to say, oh, what happens once we simulate? Now you can do the static depending on parameters. So here we see that this extends from something that depends on this H init. So meaning for all these kind of things, you can make them depend on different parameters. That could be the field pattern, it could be the visibility, the color, so on and so forth. So this gives you the freedom to adapt how your icon looks like depending on things like your initial conditions, which of course is sort of a good way of getting idea how it's set up. Now, I'll simulate this. And once simulated, we will see a plot of how well this controller actually manages to get the tank levels at the desired levels. We see here tank 1, 2, 3, each of them with an orange signal here. That's the reference. And then we have the level in blue here, the actual level, and how sort of the controllers manages. They're not very good, right? So like a lot of overshoot, and then sort of here after 150 seconds, it seems that they reach the desired level. And then as I'm feeding it a pulse of sort of rain coming into these tanks or to the top level tank, then once this comes, it overshoots, and that's sort of how it continues. But this gives me opportunity to show another of the new things. It's the ability to actually change parameters in real time. So let's say that I want to run this for infinity. And don't be afraid, I'm ready. It will just take a minute or so, then I'm ready for Q&A. So we set it to infinity, and I set it to synchronize with real time, right? And I start running it. So then, of course, if I don't do anything here, we will see it updating. It's quite slow, so let me stop it because we can't wait 1,000 seconds. So instead I say, okay, time scale, let's run it 10 times faster. I should have done that. And now we run 10 times faster, and we see that we're already up now in 50 seconds, 60 seconds, and we will see the first sort of ramp coming after 150 seconds, if I remember correctly. Yep, there you go. So here we see that the pulse comes, and we see some reaction. But as I said, a new thing now is that you can change parameters, and I prepared a couple of control panels. One where I can change live the control settings, like the constants for the controllers, and that should sort of change the behavior, and we should see a different behavior whenever a pulse goes. Yeah, so we see here the pulse came, and the behavior here is very different from this one. So it gives an idea of, if you do it more systematically, it gives you a good idea of how different parameters will affect the behavior. Or you could, of course, have things like the reference levels changing, and despite it being a parameter, it works. So basically, you can use most parameters as if they've been an input. And this is a great way to learn and understand your system better. So that was a very quick overview of what's new in SystemModeler. If you are interested in more about SystemModeler, there's just after this, there's a presentation by Eric Espinosa from Linköping University, Phantoms, MIGs, and Kinematics, the math of dogfighting. And Eric is always really good, so don't miss it. Then we have the presentations I mentioned about from Ankit and Sergio at 5:30, or depending on your time zone, in 1.5 hours from now. Let's see, in 2 hours, 1.5 hours from now, we have modeling and optimizing your thermal management in electric vehicles. Then train your AI with SystemModeler and open networking. And then on Friday, we have from requirements to validate the design, open office hours, and open networking. I also want to mention here that we have a SystemModeler virtual conference coming up in February where users will present their use cases. And with that, I should open for questions, but I realized in my slides actually skipping things. I will find a slide up here. An important update that it skipped is this, that will come in the upcoming release, SystemModeler Assistant, which will help you understand how to use the product better. So you could ask it, for instance, let's say you want to export an FMU. So how do I export an FMU? And this will then tell you step by step how you do this in SystemModeler. So with this new assistant, you will be able to go through different scenarios, and I guess this is the thing of running live. It's got stuck waiting here. We'll see an example behind the scenes here that I did. But it would give you step-by-step instructions. Hopefully it comes before I conclude. When developing WSM, are there any fields, areas that you focus more on? Right, and one of those you mentioned, the renewable energy, actually is something that we are focusing a bit more on at the moment. Yeah, it killed my Mathematica. Interesting. That's the thing of running running beta versions. Anyways, it's energy is a focus area at the moment, but it changes over time. But right now, you will see us adding more and more that relates to energy. What type of circuit model is trained, for example? Is it a normal neural network? I recommend you follow Anket Naik's presentation to get all the details and better answers than I can give. For surrogates, we have started by supporting, oh yes, Sergio already answered that. For surrogates, we have started by supporting continuous echo-state networks. So that's what we support right now. And then was there, so basically the same question, right? See if we have any more. No. Then let me just try for an extra time to see if I can get that assistant for an example, and then we wrap up if there is no other questions. Stop the simulation in case that sort of disturbed it in some way. And Wolfram notebook, there you go. Initializing kernels. This will be interesting. Open recent. This one. There you go. And let's run it and test it. So you see it sort of loads a bunch of, this is very much under development. So the answers will depend on basically which minute I ask very much. But here we have it again. So let's give it a try. How do I export an FMU? Now it seems like it's doing something, so that's positive compared to the previous attempt. And there you go. So it will give you step-by-step, open model center, select the model. It gives you the file menus and so on and so forth. And this works for, if you would ask it how to create that static expression graphic that I showed you, it will give you the instructions for that and so on. So with that, thank you very much. And hopefully you run over to Eric's talk right away.